Jai Hind everyone. My name is Ashish Dixit. I am a system professor, computer science and engineering department in Ajay Kumar Garg Engineering College. So today this topic is the complexity of algorithm and growth of function, performance and measurement in a subject design analysis of algorithm. It is a very crucial and important topic for the algorithm purpose and for the performance measurement purpose. Okay. So here what is the complexity? Then first of all, the performance analysis of an algorithm is said to be efficient and the fast if takes a less time to execute and consume less memory space at the runtime is called the performance. Means the performance will be measured by the two parts. First space complexity and second is a time complexity. Always kept in mind, if you want to make develop any program, then those issue will be measured, time and space. And always kept in mind, if you want to develop any program, then first of all always kept in mind that it will be consume a less space and execute a very less time, then its performance will be grow. Okay. So here we will discuss about the space complexity. A space complexity of an algorithm is the amount of memory space required by an algorithm during the course of execution. It is called a space complexity. It has three types of space. First, instruction space, and it is called a executable program. Okay. Second thing, a data space that required to store all the constant and the variable data of the space. And third point is a environment. It is required to store environment information needed to the resume of the suspended space. So always kept in mind, these work on the behalf of three spaces like instruction, second data space, third environment. Okay. So suppose that you want to make a program, then without the instruction it's can't be possible that it will be run. Second thing, without the declaration of the data it can't be possible that it will be performed on any function. Third thing, environment, because if you will be not able to provide an environment for the survive of the data spaces or data types and instruction, then it can't be possible that it will be running. Okay. Next time, the time complexity major concept is time complexity. Suppose that the time complexity of an algorithm is the total amount of time required by an algorithm to complete its execution. जितने टाइम में हमारा कोई भी प्रोग्राम एग्जीक्यूट होता है, this is called the time complexity. Or and always kept in mind, time complexity will be reduced if you will be take a easier function, then its time will be less. Okay. Then here space complexity, there are two types of space complexity. First, constant space complexity, and second is a variable space complexity. A constant space complexity, a fixed amount of space for all the input values, these are constant space. A fixed amount of space for all the input किसी भी इनपुट वैल्यू के लिए जो पहले से ऑलरेडी फिक्स्ड है टाइम amount of space, means this is also taken this, then this is called the constant space. So here we will take the examples. Int square int a, then here integer square int a is provide the return of a multiply a, then here the algorithm requires fixed amount of space for all the input values. These are constant space complexity, got it? Because here we will use the int square method, and if you will pass any variable, then it will be square, and after the square it will be returned, means it's a minimum space. It will be required, always required, permanently required, then it's called a constant space complexity. Second thing, a linear space complexity. This space needed for algorithm is based on size, means any linear space complexity will be depend on the size of the program or a size of the variable or the size of the array and size of the loop and size of the some variable like a subtraction, multiply, addition. Okay, these are multiple types of function that they will be take a particular fixed memory space. Okay, so here size of the variable n, then it's also taken a one word. Array of a variable values is totally depend on the number of values, means n words. Loop variants is a one word and some variable is a one word. These are taken a particular memory space. So here we will take one examples. Suppose that this is the program, sum of the numbers, then here int sum int a int n, then int sum is equals to 0 and I, it's a declaration of the variable, it's also take a one word. Then the loop is also taking the one word, and sum of the variable is also taking the one word. Okay, and here it's a declaration of the array, it's also taken a n word, then it's a return, means size is same. Okay, so here we will take examples like this is the n and this is a 1 1 1, then total answer is a word n plus 3 words. Got it? So this is the linear space complexity, or we can say that variable space complexity. Got it? Okay, next. So space complexity is the concept. The space complexity of an algorithm is the amount of memory needs to run to the complete. एक ऐसा मेमोरी स्पेस जो पर्टिकुलर रिक्वायर्ड होता है किसी भी प्रोग्राम को रन करने के लिए, पूरा रनिंग प्रोसेस कंप्लीट होता है जितने स्पेस में, उसे बोलते हैं स्पेस कॉम्प्लेक्सिटी. सो हियर वी विल यूज अ स्पेस कॉम्प्लेक्सिटी इज द फर्स्ट पार्ट कांस्टेंट फिक्स पार्ट एंड सेकंड थिंग है वेरिएबल पार्ट. ओके, कांस्टेंट पार्ट एंड वेरिएबल पार्ट, यानी फिक्स पार्ट एंड वेरिएबल पार्ट्स. Then fix, what is a fixed part? Independent of instance characteristics, independent of instance characteristics like a space for simple, variable, constant. These are a fixed part. Constant are a fixed part. Okay. Then variable, the space for variable whose size is dependent on the particular problem instances, means problem will be changed, then its variable part will be changed. Always get in mind, problem will be occurs in a different types. So according to problem we will manage the variable part, and variable part will be changed as per the requirement of the programmer, as per the requirement of the our particular problems. Okay, next. So here we will find out the space complexity. This is the program algorithm sum A B C. Okay. Then A is equals to 10, B equals to 20, C equals to A plus B. Okay. Then here constant variable 1, 2, 3, 1, 2 and 3 है. Then कितना कितना ले रहे हैं 1 plus 1 plus 1. Okay. So constant part is equals to 3. Then variable part, here we will not, here we will not take any variable space, that's why it will be 0. Then the sum of the 3 plus 0 equals to 3. Then answer is a big O, 3. Okay. Next question. Next. Algorithm sum A comma n, total 0 and minus 1 variables, then for loop 1 to n to minus 1 and 1, then total, then plus ai minus 1, then return total. Okay. So this is the examples. This is the algorithm 1 and algorithm 2. First algorithm A B C, here constant variable A B C, then also take the space 1 2 3, then value is a 3 unit. Next thing, here algorithm is a sum A comma n and then sum 0.0, then for I bar 1 to n, then sum and this. Then here it's also take a n value and this also take a 1 plus 1 plus 1. Okay. So here A is a n units, I also declare n units, and INS is also taken the 1 units. Okay. Those then the value of this is n plus 3. It's always greater than n plus 1 unit. And similar here, we will also take the examples. This is the value of a 3n plus 1, because n plus 1, n plus 1, n plus 1, it's also running on the n plus 1 times, and it's also occur at 3, then answer is a 3n plus 1. So next topic is the time complexity. Means किसी भी प्रोग्राम को रन कराने के लिए जो एग्जीक्यूशन टाइम है उसी को टाइम कॉम्प्लेक्सिटी बोलते हैं. ठीक है. सो हियर time complexity of an algorithm is the amount of computer time it's need to run to complete the program. So here we will take time complexity is the sum of compile time plus execution time. Both time will be included, then this is called a time complexity. Got it? So here a time complexity is the sum of compile time and sum of execution time. Okay. Then time complexity is also called execution time. Steps count for an algorithm heading 0, braces 0, expression 1, and for any looping statements number of times loop is repeating. कितने number of times loop repeat कर रहा है. Always kept in mind, जो भी heading algorithm है वो टाइम 0 लेती है, जो भी ब्रेसेस हैं फॉर ब्रेसेस देन 0 लेते हैं, कोई भी एक्सप्रेशन 1 लेती है, और जो भी लूप है वो कितने नंबर ऑफ टाइम्स रिपीट हुआ है हम उसके बिहाफ पे लेते हैं. ओके. सो हियर दिस इज द एग्जांपल्स. दिस इज द कंसेप्ट. This the declaration of time 0, braces 0, then variable 1, the number of loop n plus 1, then sum n, then sum a plus 1, then n, then returns 0. Okay. So the frequency is also 0, 0, 1, n plus 1 frequency, then n, then returns 1. Then the sum of this is 1 n plus 1 n, then plus 1, then 2 n plus 3. This is the total running time. Okay. Next, kinds of analysis. So which types of analysis will be available in our design analysis of algorithm? Then here we will discuss about the 3 types of complexity, and here we will develop 3 types of concept, means worst case, average case and best case. Suppose that we will take any problem and problem size is n. It's also take the maximum time of algorithm, consume the maximum time of algorithm. Then this is also considered in a worst case. Okay, means depend on the maximum time, consume maximum time. Then this is include in a worst case. And suppose that we have a one problem and we know that the expected time, okay, means we know about the problem is this and expected time will be this, we will know, then it will be considered under the average case. Sometimes may be occur and sometimes may be not occur. Maybe sometime we have the knowledge that it will be consume this time, but sometimes we do not have a knowledge that how much time will be take any algorithm. Then here we will use the worst case. But if we know about the this amount of time will be used only for this particular equation or a program, then we will consider average case. And best case, here we will use a minimum time algorithm for the input of the size n, means minimum time. If you want to use a minimum time amount of time for a particular problem, then this is also considered the best case. Okay. So here average case, it's also occur sometimes Tn expected time of the algorithm over all input of the size n, then needs assumption of the statistical distribution of input. It's totally depend on the assumption based. Okay. Then best case, a minimum time of an algorithm on any input size of n. Then the complexity refers to the rate of which the storage time grows, a function of the problem size. Okay. Next, analysis of an algorithm. Main goal of the algorithm is a goal of analysis of an algorithm is to compare the algorithm in running time and also use the memory management. Before the lecture, I also declare that if you want to develop any algorithm for a particular problem, then always kept in mind both concepts will be applied, time and memory or a space. And ऑलवेज केप्ट इन माइंड आप कोई एल्गो डेवलप कर रहे हो, डेवलप कब कर रहे हो और कैसे इफेक्टिव होगी, जब वो प्रॉब्लम पर्टिकुलर प्रॉब्लम विल बी टेक अ लेस अमाउंट ऑफ टाइम and also take a less amount of memory space, then it will be effective. Means consume a less memory space and also use a less time for execution of the particular problem, then it will be called the analysis of an algorithm. Okay. Then running time of an algorithm depends on how long it takes a compute to run the lines of the code of the algorithm. Then running time of an algorithm depends on the first speed of the computer, first point, second thing program language, third compiler translator. Maybe you have a less amount of storage in your computer, then speed is also down. Then programming language, which types of language you will be use, maybe high level language, low level language, middle level language. Then third thing is compiler and translator. Okay, these are a major issue. At fully running time, it's also depend on these factors. Asymptotic notation. So here we will discuss about the asymptotic notation. What is the asymptotic notation? First, expressing the complexity in terms of relationship to known about the function. This type of analysis is also called the asymptotic notation. Main things, it's totally dependent on the efficiency of an algorithm. That does not depends on machine constant, does not require any algorithm to be implemented, and time taken by a programmer to prepare. These things will be, does not depend on this. Okay. So here asymptotic notation is a mathematical way how to represent a time complexity. Always kept in mind, the definition is that it is the way to describe the behavior of function in the limit or without the bound. Okay. Then asymptotic growth, the rate of which function growth rate is totally depend on the time plus memory. Means how much time will be consumed by the program, and how much time will be consumed by the program, how much space, memory space consumed by the program. So growth rate will be depend on two types of function, means time plus memory. That is why we will discuss about the growth rate tends to time plus memory. Okay. So classification of the growth will be depend on the three types of concept. May be growing with the same rate, constant rate, may be growing with the slower rate, and may be growing with the faster rate. Okay. These types of will be concept will be arise a asymptotic notation. Through this we will declare the growth rate of the function. So here we will discuss about the growth rate of the function by the 5 type of notations. First notation is also called the big O notation. Second thing is a big omega notation. Third thing is a theta notation. Fourth thing little o notation, and fifth thing is a little omega notation. Okay. So here a little o is also declared by the this, and little omega is also declared by the omega. Okay. Next, a big O notation, it's also take a slow rate concept, because if a problem will be in a huge amount of the data, a huge amount of the particular memory space, then it's also declared on the behalf of big O notation. Okay. So asymptotic less than means lower rate. This notation mainly represent upper bound of an algorithm, runtime algorithm. Okay. Then big O notation is useful to calculate maximum amount of time for the execution. Suppose that you have a major problem and it's also taken a long time, and its slower rate is very fixed. Okay. Then it's also used a less amount of time, means less than means it's also consumed at a slower rate. So here we will apply different types of function. Function is a this type of fn is less than or equals to cgn. C is a constant function, g is a function. So here n is always greater than or equals to n0, c0 is always greater than 0, and n0 is greater than or equals to 1. So according to definition, we take two types of function fn and function gn. Be two non-negative means two positive function. Now we can say that function is equals to big O gn if there exist two positive constant c and n0, such that fn is less than or equals to c dot gn for all values of n is greater than 0 and c is greater than 0. This is the mathematical equation for the growth rate of the function big O gn if fn such that there exist positive constant c and n0. C is the constant and n0 is the positive constant. Fn is a function and fn is depend on the fn is greater than or equals to 0 and less than or equals to cgn, and all n is greater than or equals to n0 means fn is equals to big O gn means that there exists some constant c such that fn is always less than or equals to cgn for the large enough n. This is the function. This is the function. Okay. This is the n and this is the n0 and this is the n, and fn is upper bound. Fn is upper bound. Then here fn is greater than or equals to 0 and less than or equals to cgn. Okay, and always kept in mind n is greater than or equals to n0, c is constant and n0 is constant. Okay. Next, omega notation. Omega notation, it's also used for the greater than faster rate. It's represent lower bound of an algorithm runtime by using a big omega notation. We can calculate the minimum amount of time. Here we can say that the best case time complexity. So formula is fn is greater than or equals to less than or equals to cgn, and n is also greater than or equals to n0, c is a constant, c is greater than 0 and n0 is greater than or equals to 1. It's called a lower bound and it's also considered in a best case. So this is the mathematical function omega gn is equals to such that fn such that there exists a positive constant c and n0 such that cgn is greater than or equals to 0 and less than or equals to fn for all n is greater than or equals to n0. This means there exists some constant such that is always for large enough n, function is equals to big O gn, then fn is greater than or equals to cgn. This is the mathematical function. Here c is greater than or equals to 0 and less than or equals to fn. This condition will be satisfied here. Then theta notation, it's also say that it's a sandwich case. Okay, so हम सभी जानते हैं इसको सैंडविच केस ही बोलेंगे. Okay, it's also considered in a average case. So here asymptotically take equality same rate, it's represent a average bound of an algorithm running time. Here our main function will be sandwiched by the both function lower and upper. Okay, suppose that this is the burger, and this is the burger, and between the burger 1 and burger 2, in between we will use the cheese, burger में, मीन्स टिक्की जो हम रखते हैं वहाँ पे टिक्की रखते हैं, उसमें मसाला रखते हैं, टमाटर, प्याज, सभी चीजें। मेन दिस इज द FN and this is the C1GN and this is the C2GN. Okay, then apply करिए आप। Then here we will use this types of equation. This is our cheese, this is the burger 1 and this is the burger 2. That's why we will call the average case or a sandwich case. Same concept is a big O GN such that function there exist positive constant C1 and C2 here. We will take two types of constant C1 and C2, then function Fn is greater than or equals to C1GN and less than or equals to C2GN, and C1GN is greater than or equals to 0 for all n is greater than or equals to 0. So, Fn is equals to theta GN, this is the theta, this is the theta, okay, this is the theta. This is the function, main function. This is our function, this is the lower function, this is the upper function, and our function will be sandwich. Then this is called the theta GN, okay, theta GN. Same, a little o, it's a slower growth rate of function. These types of problems will be occur here, limit n square oblique n, then limit 1 by n, n tends to infinity, then the value is 0, okay. These are references. Thank you very much. If you face any problem, then comment in a comment box and please like and subscribe of my channel, okay. Thank you very much.